find the absolute max and mean value of the function over the region bounded by these three straight lines. We know, according to the extreme value theorem, the the absolute max and mean value of a continuous function must occur either at the critical points inside the region or on the boundary of the region. So in order for us to find the max and mean value for this function, we need to evaluate the function at the critical points as well as the boundary. So let's start with finding the critical points, and then we're going to take a look at the situation of the function evaluated at the critical points. We're going to start with setting partial x and then partial y equal to 0. Okay, so that's going to give us y equal to 0 and then x equal to 0. Okay, so this is going to be the only critical points of the function, because there's no way for the partial derivative to not exist, which eliminates the possibility of having the second type of critical point. So the conclusion here is critical point is going to be 0, 0. Okay, so evaluate the function at the critical point. It's going to have f 0, 0, plug in, that gives us 0. Okay, so the function is going to be 0 evaluated at the critical point. Okay, next we need to take a look at the situation of the boundary of the region. Obviously, the region is going to be bounded by these three line segments, right, which is denoted by C1, C2, and C3. And then what we're going to do is that we're going to find parametric equations for each of them, and then evaluate the function on each of the line segments. Starting with C1, so along C1, okay, we can observe that the y-coordinate for each of the points on this line segment is always 0, while the x-coordinate ranges from -1 to 0. So the representation of this line segment can be written as x is going to be t, y is going to be 0, where t ranges from -1 to 0. And then we're going to evaluate the function on this line segment and denote the function by g1. G1 is going to be f of t0, okay, and then plug in, that gives us 0. So we can see that the function evaluated on this line segment is constantly 0, regardless of the value of the t plugged in. So that tells us that both the max and mean value of this function is going to be 0. So g1t max equals g1t min is going to equal to 0. Okay, and then take a look at the situation of this line segment C2. Right? Each of the points on this line segment is going to have x-coordinate equal to 0, while the y-coordinate ranges from 0 to 1. Okay, so we're going to have along C2, we're going to have R2 of t equal to x being 0, y being t, where t ranges from 0 to 1. And then we're going to evaluate the function by plugging in, so that's going to be denoted by g2, right? Plug this 0t into the function, so that gives us f 0t, which is also 0. Okay, so the function evaluated on C2 is also constantly 0, which tells us that g2 max equals g2 min equals 0. Okay, so far we have already finished C1 and C2. So let's take a look at C3. Okay, C3 is going to be a little bit more complicated. need to figure out a parametric equation for this kind of the hypotenuse of this triangle here. So just notice that the choice of parametric equation is never unique. You can have so many different ways to parameterize a line segment. And one of the easiest way is to just let x to be t, and then you solve for the y value from there. So we're gonna take that. We're gonna have this denoted by R3 of t. It's gonna let x equal to t, right? And then because x is equal to t, we see that y is equal to t plus 1. So this is denoted by t plus 1. Of course, we also need to find the range of t, right? And then because we know that x is t, so the range of t is just the range of x. So we take a look at each point on this line segment, right? For a point to range from here to here, we see that x ranges from -1 to 0. So you see that t ranges from -1 to 0. And then do the same thing, evaluate the function on this line segment. We're going to have f t and t plus 1, plug into the function t and t plus 1. That's going to give us t multiplied with t plus 1. It's going to be a quadratic function. There are many different ways to find out the max and mean value of a single variable function. You can try to find the derivative and set a derivative to 0, right? Or you can just simply graph the function. Because it is pretty simple, so we can just graph it and then figure out the max and mean value from the picture. Okay, so we know that it passes through the origin and also passes through the point -1, 0, and then have the opening facing upward. So let's graph this parabola. So there's going to be a like this. This is -1 and then 0. T-axis, G3 of t. Okay, parabola like this, and then this parabola is symmetric about the vertical line, x equal to -1/2. Okay. And then because we are working on the interval from -1 to 0, so we see that on the interval from -1 to 0, the max value is going to be obtained at either of the endpoints, and the mean value is going to be obtained at the vertex here. So G3 max is going to be equal to 0 according to the picture, and then G3 min is attained at the point t equal to -1/2. And then we plug -1/2 into this thing here. That's going to give us -1/4 as the mean value. Okay, so far we have finished discussing the situation, the function evaluated at the critical point, and also the boundary by discussing it in 3 situations. Okay, and then we compare all the values from here. We see that the max value is going to be 0, right, according to the comparison, and the mean value is going to be -1/4. So right now we can make our conclusion. The conclusion is going to be max value for the function 0, while mean value is -1/4.